Hi folks, so we have been working with polynomials lately, and we have been adding them and subtracting them and multiplying them and all sorts of things. And we just recently had an assessment on that. So we are going to be continuing our work with polynomials the next couple weeks, but doing some different things with them. And so one of the skills that we're going to need when we are doing those other things with polynomials is we're going to have to go back and we're going to have to recall kind of our rules of exponents, particularly with our dividing with our powers. So I wanted to do a quick video to refresh your memory on the rules of exponents when you're dividing with powers. Because as we continue to work with polynomials going forward, we're going to have to recall how to do this type of division, okay? So let's think back to when we did this before and we were dividing. If you remember correctly, there was two things to deal with. There was the number part to deal with, the coefficients, and then there were the variable parts to deal with. So first of all, let's start with the numbers. Remember what we said you could do with the numbers is really just reduce them like you would if it was a regular fraction, right? So 12 divided by 2, right, just reduce them as if it's a regular fraction. So 2 goes into 2 once, and 2 goes into 12 6 times. So in our answer, that's going to end up as 6 over 1, right? Which I don't really need to write the coefficient of 1, so I'm just going to write the 6 in the numerator. I'm not going to write the 1 in the denominator, right? Now, with the variables, okay, remember our shortcut was to subtract the exponents. So x to the 5th divided by x to the 3rd. These 3 cancel out with 3 of those, and there's 2 left over, right? Subtract the exponents. So these 3 are gone, and there's 2 left over here. So that's going to be x to the 2nd left in the numerator, right? And now here, y to the 2nd divided by y. Remember, if there's no exponent, it's always a 1, so it's y to the 1st. So again, I can subtract the exponents, 2 minus 1. And that means there's going to be 1 y left over. And since there's more y's up here, the leftover y is also going to be in the numerator. So this y cancels out with one of these, and that leaves y to the 1st in the numerator. So the only thing left in the denominator is 1. So you end up with 6 x to the 2nd y over 1. Right? And since it's divided by 1, that really doesn't do anything, and so we can just write 6x to the 2nd y. That's our answer. Right? So when you're dividing with powers, you divide or reduce the coefficients just as you would if it was a regular fraction, and then for the variable parts, you keep the base and you subtract the exponents. But you just have to pay attention to where the leftover variables are. If there are more x's in the numerator, then the leftovers are going to go in the numerator. As a later problem will show, if there's more leftovers in the denominator, then you have to leave the leftover variables in the denominator. Okay? So let's do another one. 36 over 40. Now, that doesn't divide evenly like this did, 12 divided by 2 being perfectly 6. But we can reduce it like a fraction. Think of a number that goes into 36 and 40. I think 4. Right? So 4 goes into 36 9 times, 4 goes into 40 10 times. So I know I'm going to have a 9 in the top and a 10 in the bottom of my fraction. Okay? Now let's look at the rest of the variables. I have x to the 1st divided by x to the 1st. Right? Well, time you have something divided by itself, it cancels out to 1. So the x's are going to completely cancel out. There's going to be no x's in our answer because x divided by x is just 1. All right? Now here we have y to the 3rd and y to the 1st. So subtract the exponents. That's going to be y to the 2nd. And since there's more y's in the numerator, the y to the 2nd left over will be in the numerator. Right? And then here I have z to the 4th divided by z to the 3rd. So 4 minus 3, that's going to be z to the 1st left over. And since there were more z's in the numerator, the leftovers are going to be there. Okay? So that's my answer. 9 to y to the 2nd, z over 10. The only thing in the denominator is 10. If you want to center that 10 to make it a little bit look nicer, that's our final answer. So remember, you're reducing the numbers just as you would if it was a fraction. And then the variables, you're subtracting the exponents. Keep the base, subtract the exponents, and just pay attention to where the leftover variables go after you divide. Do they go in the numerator? Do they go in the denominator? In this case, there were no leftovers for the x because x divided by x cancels out completely to 1. Okay? All right, let's do one more here as a refresher. Okay? So, again, 18 over 24, let's reduce that. So what goes into both of them? All right, think about what goes into both of those, and you can do, whatever. If you don't get the biggest factor first, then you can just keep reducing, just like if it was a normal fraction, right? Think about what goes into it and reduce it. So I know 6 goes into it, right? But maybe by accident you said, oh, I'll divide it by 3 or whatever. That'd be fine, but you just want to reduce it as far as you can, as much as you can, like a regular fraction. So I'm going to do 6 though. So 6 goes into 18 3 times, and 6 goes into 24 4 times. That will get me to lowest terms. Again, if you divided by a smaller number, you wouldn't get to lowest terms. You'd have to keep dividing. Okay? So I know I'm going to have a 3 over a 4 here, because I reduced the 18 over the 24. Now, with the a's, I have a to the third divided by a to the first. So that's going to be a to the second. And since there's more a's in the numerator, my leftovers are in the numerator, a to the second. Right? Because this a cancels with one of those, and there's 2 left over in the top. Okay? Now, with the b's, pay attention. B to the first in the top, b to the third in the bottom. That's going to be 2 leftovers. 3 minus 1 is 2. But since there's more b's in the denominator, that's where the leftovers are going to end up. This b cancels with one of these, and now you have b to the second in the denominator. So remember when we did that in class, that's how we had to think about it. Right? Same thing with the c's. You have c to the first in the numerator divided by c to the fourth in the denominator. So this c is going to cancel out with one of those, leaving 3 in the denominator. C to the third. Final answer. Okay? So, again, in this problem, after you did the dividing and the canceling out, some of the leftovers were in the denominator in regards to the variables. So wherever there are a larger number of the variable, that's where the leftovers are going to end up after you divide. Okay? So hopefully this jogs your memory and gives you a good little refresher of what we did when we were dividing powers. We'll do a little bit more practice and work with this today because it's going to lead into some more work with polynomials where we're going to need to recall this dividing that we did. So that's why we're spending a couple days at the beginning of this week just reviewing this stuff so that we'll have it when we need it to apply it. All right? Have a great day.